So mic is enabled for you. Just be careful. Today I'm at some another location, so don't have the additional display. So you have to use mic if you are putting something on chat. It may not be visible. Still, I have made the arrangement with an additional device, but just try to have your query by unmuting yourself, right? So first, I would like to discuss a bit about the EC2 examination. Many of you have done exceptionally great, and I'm really amazed to see the performance. Few of you, those who were really active during the sessions as well, like you, Raj and Jyoti. Apart from that, Ravi is always active. So uh, you came up to the expectation, and altogether means I was wondering where I should deduct any mark for you people, right? So that is somewhat good thing. Many other people have also came out with a good score, those who were not active during the sessions. But the problem is, many of you have not even reached to a double digit figure. So that is not somewhat expected because everything was communicated well in advance. And if you would have gone through the slides or if you would have gone through the recordings, even in a fast forward way, you should have got the basic concept. Mathematical calculations were there, very easy calculations were there. If you would have spent somewhat 4 to 6 hours in total, then also you would have uh, done a good score, right? Why I'm telling all this is for all subsequent means EC3 will be there. Apart from that, assignments will be there. So just try to concentrate on the sessions, right? So because I am taking it comprehensively, a lot of extra material is also being communicated, right? So that is the reason. For EC3, definitely it will be open book, but all the inferences will be drawn through the PPTs and the sessions only. Right, and it's quite obvious. Means psychologically, if your faculty is putting some more emphasis on a topic, say it be Murray's law, a lot of emphasis was there. Cache management and the numericals, a lot of emphasis was there. So accordingly, you can take a decision and put some more concentration because few of the questions were tricky, and I was happy that many of you have done it in a great way. Means even the theoretical answers that you have given were awesome, right? So I would expect that at least put some efforts. It's not that tough. If you consistently give 4 to 6 hours only, I understand your situation that you are working somewhere and then you are coping up with all these situations. But this is somewhat you have already gone through in your undergrad degrees if you are from the CSE discipline. Right, so try to go through the slides. At least you should know what exactly is available where, right? So that is the main concern. And if you go through the recordings, all the analytical questions can also be solved because somehow I give the clue and then through that clue only I frame the question. Okay. So we have started with the basics of architecture, organization, the generation of computing. Then we have gone through the concepts of caching. After caching, we have seen the architecture as how exactly the system architecture comes into picture. Okay, and later on, we have gone through the concepts of microprogram versus hardwired control units, pipelining, the concept of pipelining, and many more other concepts we have gone through. So, as far as the basic computing hardware part is being considered, we have thoroughly covered it. Next in line, as per the curriculum, is the processes and threads in view of the cloud infrastructure. But what I feel is until and unless we go through the concept of data centers and until and unless we go through the concepts of virtualization, then the concepts of containerization, say it be Docker or so. So going through the processes and threads will be somewhat difficult. So I have reshuffled it a bit. We will start with the concept of data center, that is the module 7 and 8, and then we'll be coming back to the concept of process threads and deadlock over here. Right. So this will be the basic flow. I'll be communicating through a message in Teams as well, so that it will be in your records. Okay. So we'll start with a short video. Hope it is audible. Anyone can respond, Gautam. Yes, sir. Okay, thank you.
The view may be generic, but this is actually one of my favorite places in the world. Why? Well, I think it represents the most important infrastructure of the 21st century. This is a part of Microsoft's Columbia data center campuses. These house the computers that fuel our lives. There are more than 20 buildings, each large enough to house 2 commercial aircraft. They fill 2 million square feet. They're spread out over 300 acres. But what's really interesting is what's inside. It's something that almost no one ever gets to go see. But come with me. It's COVID times. I need to wear my mask, but I'll show you around. Well, as we walk around, first, I've just spared you not just a metal detector, but what is probably the longest and most substantial security checkpoint you'll ever find on planet Earth. But what is so interesting to me is what you see here. This is just a glimpse of the types of server computers that we find in room after room and building after building on these campuses. There are almost 500,000 of these server computers. They store as much data as you would find in more than 50,000 libraries of Congress. And I think that captures so well how this really is the infrastructure for almost everything that we're engaged in today. The way you live your life, the way you do your work, the way research and development are all moving forward. It all relies on this enormous amount of data and this enormous amount of computing power. So you just see here so much innovation all connecting together. But actually, that's not the end of the story. Come back outside and I'll show you one more really interesting piece. These campuses represent not only the most advanced digital infrastructure in the world, but some of the most advanced energy infrastructure as well. Why? Well, first,
Right, so that was the main intent. At least you should have an idea about the number of buildings, the number of servers, racks these buildings are carrying out. Okay, and it's huge, means it's Microsoft data center, and apart from Microsoft, if you see the Google, excuse me, and other huge data centers, then they are really huge. If you have heard properly, then this data center itself was having hundreds of such buildings, and they have given the relativity that each building can house 2 commercial large spacecrafts. right? So that is the magnitude with which these data centers are working, and definitely there is a need. If you see, then in World Cup, when I was watching the match on Hotstar, the number that they have given is somewhat 32 crores or so. So just imagine if 32 crore people are watching, and just see the volume of data that may be transferred. So what level of data centers and what level of computing is at all required when such a magnitude is being required corresponding to the data flow, right? So ultimately, whatever we have seen, ultimately we have to go through the concepts of cloud computing. But if you see down the line, somewhere we are having the data centers in place, and because of these data centers, we are able to get the concept of cloud computing, right? So today we will be exploring as how exactly data center works, not only in terms of the basic computing things, but also in terms of power and cooling, because that is something being mentioned in the curriculum. So we will be looking into the power aspect as well, because if you recall, then when we were talking about the generation of processors, so at that time I was telling you that many times the generation change brings only the power wattage down, right? So say it be if it is shifting from sixth generation to seventh generation of i7 processors, so maybe the case that only power wattage is low in the new generation, rest all features remain same. And that is usually the case whenever the change in generation is being there. So in earlier times, when I haven't gone through this subject or this course, so that time even I was wondering that why it is so. Means why they are working on change in the power wattage only, and releasing a generation. Because for me, if it is coming from 120 to 100 watt, right? So for an individual, it is only 20 watt that is being saved, right? And even if I work for say it be 10 hours, so you can just calculate that it's only 2 units that are being saved, right? So that way you can think that, okay, why exactly it is being required. But when it is of thousands and millions of processors running in the data center, and if this is the case where you are having a multiplier of 20 watt, then after having multiplied with the number of the processors, the number is huge. And one more reason is the energy consumption, green energy. That okay, if you are able to save the energy, if you are able to save the power, so that way uh, you are somehow saving the nature, right? So these are all the reasons that are being seen whenever you are working with the data centers. So now, why exactly means already we have seen, but theoretically we will just go through it. That why we should study data centers, right? So whenever we have to go through the cloud infrastructure perspective from an end-to-end perspective, then obviously we should go with the large proportion of cost. That is, even in we can go through the capex, that is the capital expenses, or the OPEX, that is the operational expenses. Ultimately, the whole thing will be derived through the data center only. So those who are working only on the software part and never being into the data center facilities, right? So for them, definitely this will not be required in their whole life at all, right? But at least you should have a knowledge so that Say it be if you are having any in-house facility and you'd like to go through a hybrid cloud infrastructure. So until and unless you are having a knowledge of basic data centers as what are the facilities that needs to be managed, and somehow you have given a task to lead the hybrid infrastructure and your on-prem infrastructure, then you should know what are the facilities that will be required within the data centers. So whether you will become a part of data center, or if you are going to be working with the hybrid infrastructure, or at least if from a cloud perspective, if you would like to have the basic knowledge, because if you will be declaring yourself as a cloud engineer, so ultimately you should know how exactly the cloud is being delivered through the data center. So that is the main intent. Data center is usually called as the first layer of cloud computing, and that's why the basic knowledge is very much required. And whatever be the cloud cost model, because apart from the software layer, the whole hardware cost comes from the data center part, and that's why you can say that okay, mm, we should definitely go with this, right? So whenever we will be talking about the data center, it is usually said that it is following the 3 plus 2 model. Okay, so you can just have a look as what we are going through in 3 plus 2. So whenever data center is being talked about, space is one of the major criteria, then the power and the cooling facility. So based on the capacity of, or based on the values of all these three, data centers are being compared, right? So either data center may be compared in terms of power they are carrying or they are utilizing. Data center may be compared based on the space or the number of racks they carry. And finally, the cooling capacity that is being required, because somehow that gives an idea as about the magnitude of the data center. In all these, two auxiliary components are there. That is, one is the fire and other one is the physical security that is to be maintained. Right. So, looking into all these, we have a great reason why we should understand about the data center facility, how it is being linked with the cloud computing infrastructure, and finally, the cost impact of data center on the cloud business. Right. So, whenever we are dealing with cloud cost analysis, definitely there is a software part that drives the whole cost, because it's not about the hardware, right? So right now we are talking about only the data center, which is the hardware part. But apart from this, you will be having software layer in terms of virtualization, because nowadays you cannot have a data center directly giving the machines as is, right? So that time has been gone. Means earlier it was the case when virtualization is not prevalent, and that time the remote access to physical machine was usually given, and the whole setup was usually made on the servers only, right? And nowadays you need the virtualization, not only the virtualization. Apart from virtualization, you will be needing the core software stack layer through which you can deliver the various services of cloud computing. So just like we have seen that infrastructure as a service is there, then platform as a service is there, and software as a service is there. So it's not only one layer that is being delivered through the cloud. So software layer also plays a big role whenever any cloud computing service is being delivered. So these are the major services. Apart from that, there are n number of other services that can be delivered. Say it be the desktop as a service, etc. Means there are n number. Say it be network can be delivered as a service. storage as a service. So a number of things are there, but ultimately the broad categories are IaaS, PaaS, and SaaS, right? So within this, definitely software layers will also be there, but apparently, if we talk about the hardware part or the data center part, so these are all the components that will contribute towards the cost. So you can see that overall facility, then the power distribution unit and cabling, data center cooling, effective air distribution, as what exactly is the planning of the engineering where the air distribution and the airflow is being planned so that it is reducing the overall cooling requirement. Right, so this exactly happens in our home as well. So if we are having a proper ventilation, not only that, if the roofs and the walls are being painted with appropriate paints, then definitely the cooling requirement from the ACs will be somewhat less as compared to if nothing is being planned. What are the cooling strategies that are being planned? And finally, the fire suppression and physical security. So these are all the things that will contribute towards the cost. Now, coming to the how we will measure the data center capacity. So I've already told you that it is either in terms of racks, say it be the number of racks installed, and it is quite assumed that okay, if rack is being installed, then it is usually full. It will not be the case that okay, I'm having 10 racks, and within those 10 racks, I'm having only one server. So a data center person will never do this. So it is assumed that if it is 42U racks, we will see what is 42U. So they are all full, and apparently the servers or the networking switches are there corresponding to the data center, right? Second is the physical size of the building in a square meter or square feet. So this is one more way to measure the capacity of the data center. And finally, the power capacity. Say it be what exactly is the megawatt through which a particular data center is running. So these are the usual capacity. Yeah, Gautam, you're having some question. Gautam, you have raised your hand.
I'm audible?
Yes, yes, you are audible.
Yeah. So the square feet, how it contributes to the um, capacity
That is just that will give you just an idea. Uh, just assume
how
that
many
say it
racks of
be
servers per square feet.
yeah, yeah. So because it's somewhat so the people those who are well versed with the concept of data centers, so they usually know that what exactly is the ratio. So you will see in future slides that there is a terminology that data centers usually use, and that is white space and gray space. Right, so the ratio is being usually defined that okay, if the data center facility is being laid down in this much of area, then traditionally what will be the white space? And white space is the space in which the IT equipments will be kept,
Hmm.
and the gray space will be the non-IT equipments, and the vacant space will be there. So that ratio is usually being defined, and because of that, you can at least assume that what exactly or how big is the data center, or at least you can compare
Okay.
directly. So if you are having values of two data centers in terms of capacity, building square meter or so, so that way at least you can compare that if they are being made in standards. So if you follow the standard, then definitely you can compare the two data centers, even if it is being mentioned in the square meter or the overall size. Usually it is in power, right? So usually it is means traditionally it is being expressed in terms of power, that what exactly is the megawatt capacity drawn by the data center, because we always assume that they will be optimizing in all the cases, means they will not be wasting the power, making optimized utilization, because ultimately they have to pay for the power consumptions they are making, right? And that's why prior the first choice is the power consumption, but also they are being measured in number of racks and the overall area. Okay. Someone else has also raised the hand. I'll just check. Or you can unmute yourself.
Sir, this is Ajit.
Yeah,
I
Ji.
I do have one question on the data center as a service. You mentioned on one of the slides.
Yes,
What
yes, yes.
what does it mean? Like how to get that service? Is it open to individual or it's open to the corporate?
That
Because
is open to the enterprise in most of the cases. Individual, I never feel or I never have seen the requirement for an individual to have a data center as a service, right? So you can consider it that okay, you want something in between that of on-premises and cloud,
Mhm.
right? In the sense that, say it be on-premises, you will be having the full freedom to access your hardware, to manage your hardware, to configure your hardware. While in case of cloud, if you are even if you are going with infrastructure as a service, there will be few limitations that say it be if you are going for any virtual machine and that virtual machine within that virtual machine you would like to go through a containerization concept, so you may or may not be able to create the container out of it, right? So that way, if you want some more freedom than that of infrastructure as a service, but at the same time you don't want to have a capital cost or what we can say the capex somewhat equivalent to that of on premises. So in that case, companies usually go for data center as a service.
Got it. It's kind of like if I want to buy 100 servers, instead of buying
Yeah, so
that one,
rather
I
than
will.
buying 100 servers, you will be requesting the service provider that okay, I don't want infrastructure as a service as a on a restricted way. I want to do my own configuration. I'll be having my own software layer so that I can be deciding on the number of configurations and all. But that freedom we will be needing, and through that they will be delivering us a data center as a service where the level of controls will be more than that of infrastructure as a service and maybe less as compared to the on-premise data centers. But we will be having a freedom that if the resources gets obsolete or we don't need them at a later stage, or if we want some newer version of the resources, so in that case we will be having a freedom to change the resources without much of the change in the capital costs, because mainly we are dealing with the operational cost. So when the requirement is for a shorter time or when the requirement is variable, means it's not fixed that all the time you will be going with the same kind of resources for the next upcoming 3 or 5 years. So in that case, it's better to go with these kind of services like data center as a service.
Got it. Got it.
Yeah. Okay. So just a minute, I have lost my mouse pointer. Yeah. So this is just what we have seen. Now, comparing the size that, okay, when we call it as a small data center, then it is somewhat 50 kilowatt or 500 kilowatt power consumption. The rack capacity may be 5 to 50 racks. And usually the size is, and this is how Gotham you can have the comparison that if it is 100 to 1000 square feet, So usually, as per the standards or as per the traditional configuration, the maximum capacity of the racks you can have within such 1,000 square feet, or that is 5 to 50 racks, and apparently we can have the power consumption of 50 to 500 kilowatt, and that's how you can at least predict. Okay, yeah. Tell me, what is the concern?
Sir, here the rack means the horizontal portions and the vertical missions, right? Whatever shown
Racks,
in the
yeah,
video.
we will come to it. That is a complete section within the module. So rack is somewhat, I am terming it as the cabinets, right? So in computing, we are having a small cabinet that we usually use as a desktop. We call it as a desktop, right? So here in case of data centers, we are having racks, right? And within racks, you can have the analogy somewhat similar to that of desktop. The only difference is that these are there is some terminology. Say it be if I am saying 42U. So this means some device which is of 1U, and such 42 devices can be accommodated into U. This and 1U is usually, as per the standard, it is 1.75 inch. So what does it mean? 42 such devices, say it be the rack servers, can be placed into these racks. There may be some devices that are more than one U. Say it be, this can be 4U. So if storage is there, this storage can be of accommodating 4 unit of space. Right, so this is what we mean by rack. So if you recall the video, in video there were continuous racks placed within those racks. These servers, that horizontal servers will be there. So two terminologies are usually being used. So this kind of systems that we are having, the desktop, or even if you use some high-end Xeon processor, right? So this is called as tower configuration, right? So because it is being in a standing position, so that's why it is being called as tower configuration. And this is somewhat, you can say that these kind of 1.75 inch of server is there. The processor, the motherboards, and everything is specialized as compared to our motherboards and all. Even the processor, if you see, our processor are having some kind of legs into it. I'll have a comparison of the processor as well. But here, in case of these rack servers, so they are not having legs within it. So we'll see the comparison as well. I hope you got the point.
Yes. And
Yeah.
one more follow-up question is that one server will be accommodated in the one rack.
It all depends on the configuration. Say it be. So this rack, this unit will be called as rack, right? So this whole cabinet or this whole huge cabinet will be called as rack. And if supposedly I am not putting any networking switches into it, the networking switches are somewhere else, and here only I am having the servers. And supposedly my one server takes the space of one U. I hope you are getting the nomenclature. So 1U in the sense that 1.75 inch, or you can say it 1U in general. So if it is 1U space that it is utilizing, then within 42U, you can have 42 such servers uh, within this rack. Not only this, if you are talking in terms of processors, So this may be the configuration of one server, and you may be dealing with multiple processors as well. So this may be Xeon processor, this may be Xeon processor. Even nowadays, when we are having the multi-core configuration, then also we are having the concept of multi-processors, right? So two processors within the single server may be possible, and this is how the whole configuration works, right? I'll just take you to the concept that time. So this was the topic altogether, but we will cover it now itself because the question has been read. So you can just have a look. These are the downloaded pictures. So you can see that this particular unit, this is called as rack. This comes with some standard dimensions, say it be 4U, then 42U, and so. And this you can see the service, and because if you can see the relativity, then this is somewhat around 3.5 inches. So altogether you can see that it is occupying 2U, this is occupying 4U, and like this. I have also included pictures of one of the cluster we are having at our premises. So now you can see that this is the basic view. So this is the closed view, that okay, door is closed, some mesh structure is there so that air can pass through the rack, and you can see that down the line it is the RAID storage. So RAID storage, you can just assume that it is for you. Then we are having GPU node. So this is the GPU node again, the server having the GPUs, right? This is the compute node because we were needing the compute facility as well, where we'll be needing 2 TB of RAM and some good number of cores. So that's why along with GPU node, we have included the compute node as well. And this is the controller node. Why? Because when you will be putting the software layer ultimately to club all the hardware, right? Just see that we are having a storage. So this storage is of 188 TB, and it is utilizing the RAID level 6. So if you have gone through the RAID levels, so RAID levels is somewhat maintained for what we can say replication of the data, so that even if from one drive it is being lost, it can be retrieved from the another drive. So where all this control will come from, right? Because this is not a data center, it's a single rack that is being maintained as a cluster. So that's why here itself we are having the controller node, right? So this controller node is the central node that is controlling all the units over here. That is the compute node, GPU node, and the RAID service. Apart from this, we are having the switches at the top, and that's what I was telling you. It will depend on your choice whether you are having the switches within the same racks or not. Within data center, what happens is in data centers there are usually two configuration. In one configuration, the switches are being kept on the top of rack only, right? And in one configuration, it is being kept at end of row, and that is called as EOR. That is okay. There is a complete row of racks. Say it be 10 such racks are being there. So when we are going through these racks, so none of the rack will be having the networking switches. All the networking switches may be there at the end of the row, and this is again the configuration. So this is the top of the rack configuration because we don't have any option. right? So it is the single server that is being maintained. This is the single cluster which we are maintaining in this particular server room. So that's why we have accommodated everything into this rack only. So I hope now you got an idea about what exactly is rack, or what do we mean by rack. Okay. So as we have already seen small and medium, and they can be large and hyperscale data center having the 1 lakh square feet of size, and usually utilized for cloud computing, right? In terms of capacity, then it's tens to thousand millions of servers are there, and the power consumption usually goes is 50 megawatt to 1000 megawatt, right? So Amazon, Google, and Microsoft Azure data centers. So they usually comes with this kind of capacity, right? So that way you can put some good AI workload to these data centers, right? If we would like to visualize as what are the various services that will be delivered within the data center, so you can just have a look. This will give you a basic perspective. So altogether, mm, it comes uh, with from an general engineering perspective. Within data center, you will be having mechanical rooms, electrical rooms, so that the stuffs related to cooling through the mechanical devices, or what we can say the electrical rooms, so that appropriate power supply can be maintained. So such rooms will be there. From communication perspective, we will be having a lot of terminology, just like LAN rooms, network closet, or network rooms, telecommunication. Apart from LAN, there may be some communication needed through the by the employees. So that's why we will be needing the telecommunication room, or we will be needing the room from where we can control the whole network operations. From a storage perspective, again, we can think of the network storage space, backup rooms, disaster recovery sites, and from compute perspective, we'll be having the server rooms or the computer rooms. So if you recall the video again, the person have entered to an area and then enter to the this server room also. But apart from that, all of these rooms will be required whenever a data center needs to be planned. Just to give you a vision, nothing to do with the curriculum part. Excuse me. So these are the example data centers. You can just have a look. Usually they are into some remote areas or some respectively cooler areas where the power requirement for the cooling can be reduced. Okay. Microsoft, if you have heard the news, then recently Microsoft has closed one of its data center that was within the sea, right? So, but it happens that usually data centers can be placed within the sea as well. Okay. If we talk about Microsoft, then you can see that this map shows the various data centers they are having around the world. And if you see the Asian part, then also within Asia, they are having a lot of data centers, right? Specifically, just to give an idea, quickly we will go through the AWS data center as what exactly are the facilities that usually a data center carries, and that will be clear by the verbal meaning only, right? So four layers. So AWS data center, they have divided it into usually four layers. One is the perimeter layer, and because it is called as perimeter layer, somewhat on a surrounding basis, right? Second one is the infrastructure layer. And infrastructure, by infrastructure, they usually are naming the equipment, building equipments and the system that are keeping it running. Data layer is there, where the whole, uh, what we can say, the data is being maintained, the software layer carrying out the whole data, the backups, the encryption. So how all these things are being carried out will be controlled by the data layer. And finally, the environmental layer. Apparently, we should be focused about the environment as well. And nowadays, there is a huge talk about the carbon credits and the green computing. And that's why environmental layer is very much required. So quickly, we can go through one by one. Right. So perimeter is something somewhat in terms of physical security you can mainly talk about, where security in terms of guards, fencing, feeds, intrusion detection technology, and some kind of measures that can be taken in terms of the on-premises infrastructure is being considered, right? Infrastructure, everything related to infrastructure of the data center in terms of building, in terms of cooling facility, in terms of the power supply, just like you can see the HVAC system, which will be used for cooling, fire suppression, and everything comes under this. That is infrastructure layer. Then data layer. So maintaining the complete data protection will be the responsibility of this layer, right? And overall, I have included this particular physical and environmental control cases within the data centers. Although slides corresponding to each one of these entities being there, but this is just to give you an idea as what are the various facilities or what are the various services that are being required whenever a data center is to be planned, right? So secure design, obviously, a secure design will be required. Then surveillance and detection. So you should be able to log the incident. You should be able to detect the incident if it happens. So for that, appropriate surveillance and detection mechanism will be required. Device management in terms of servers, racks, uh, storage, networking, and everything needs to be managed. Operational support for cooling, then for power management, planning, and overall operational support will be required. Infrastructural maintenance, governance, monitoring will also be required. So this is related to physical. This is related to the software part that okay, appropriate monitoring and logging should be there so that if anything happens, then at least we would be able to track physical access and business continuity and disaster recovery need also to be planned. So it be whatever be the technological changes, whether the data center is adopting those changes at the same time, if some disaster happens, so corresponding to that disaster, how exactly the system will be catering to it. Okay. Now coming to the data center, I think we have discussed a bit about this, but uh, today we'll be discussing it in more detail, right? So this you might have heard a data center named as Yota, and why I've included this picture. He is Mr. Sunil Gupta. Usually he is tagged as a data center man of India because he has uh, given some foundation for the data center infrastructure within India. And some months ago, he was with Yota, that is the data center by Hiranandani Group. So Hiranandani Group, one of the big builders of Mumbai area, and now they have entered into computing infrastructure as well. And the total investment they have planned is somewhat around 36,000 crores within this data center, because what Gautam have asked is the data center as a service, because now government have started restricting about the data, that okay, the data is peculiar, and we cannot host many of our services outside India, right? And companies like Google, Microsoft, they also don't want to pose their whole infrastructure within India by themselves, because again, the case is government changes, and if the policies are not uniform, apparently they may have to leave out at some time. So that's why, owing to this particular risk, these companies are also preferring that somehow if we can get some readily available space through some infrastructure developer, and if we can have our facility on this infrastructure, and at a later stage, whenever they have decided to move out, it will not be a big deal for them, right? So that's why Utah, which is one of the biggest data center, we can say, an Indian data center within the Indian premises, right? So Utah is the name of the data centers, and they are having at different places. Cloud, as far as cloud is being considered, that is they named it as Shakti Cloud, and the things are somewhat different. If you see, then the Microsoft data center that you have seen is somewhat flat and somewhat of a warehouse shape, right? But here it is not just like a warehouse. Here the data center is somewhat a multi-story building kind of space is being utilized. So they are doing it differently. Let's see whether they will succeed or not. All right, so just have a look. So Yota G1, that is Gujarat data center, then Navi Mumbai, then D1 for NCR Delhi. You can see the area, built up area, then and the power consumption that is being done. Right, so hosted in India, and you can see the Navi Mumbai data center that is having 7200 racks. There is one unit known as PUE, that we will see what exactly it is. For the time being, I'll just tell you the full form. It is known as power usage effectiveness. Right. So it measures that whatever is the power that is being consumed, how much of the power is being used by this IT equipments. Yes, Zanil.
Yeah, hi sir. Sir, I had a doubt. Like, don't we already have infrastructure? Like, I've seen NIC somewhere written in government websites, like hosted and managed by NIC,
Yeah,
something like that.
NIC, so that is for government. But
Okay.
nowadays, just nowadays, government has posed a condition to many of the private players as well that based on their business they are carrying, they cannot
Oh,
keep their data outside India, right?
oh, okay.
So,
Data residency.
yeah,
Okay.
yes, yes. Say it be insurance or
Yeah,
banking.
yeah, yeah. Got it.
If, yeah, so that is
Mhm.
the reason. Definitely, and I say
Oh,
these are all having their own data centers and all. But
mhm.
nowadays, they have imposed on private players as well that your data should be within India only.
Okay,
Yeah.
sir. Got it.
Okay. Yeah.
Sir, one question here.
Yeah.
If you, as you rightly said, the way Amazon and other bigger players data centers are panned out, those are flat, as in not multi-story kind of a thing. But here,
Yeah.
what we are seeing are multi-story. Now, that is a very high shift in thought process, right? So there must be
Yeah.
some original thought process which says that it needs to be kind of a warehouse setup. But if there must be certain specific reasons, right?
Yeah.
And those are going to
Definitely.
be get
Reasons are there
challenged,
again.
correct? So
Yes.
how those are kind of mitigated at a high level at least? As in, if we go with multi-story, that looks like an apartment.
Yes.
So
And
area is also very
really
small.
they are having, yeah, area is small and really they are manufacturing their data centers on this kind of infrastructure only, means multi-story infrastructure only.
Correct. Wouldn't that break kind of basic principles which would have been thought about when warehouse kind of data centers were established?
I
And
totally
how
agree,
those
and
mm,
I think that is the basic requirement, and because of that, all of these companies are ultimately following that infrastructure strategy, right?
Yeah,
But
I don't
here,
think, sir, these are heavy equipments, right? Mainly racks and servers. We can,
it's
if
not
someone
about
wants, that can,
heavy, but the thing is,
heaven,
it can be
the
configured
space will
multi-storage
be
also.
requiring. Uh, Mm, No, no. My point is that ultimately we will be needing, like if you are having a warehouse kind of infrastructure, then uh, air passing and
airflow.
all those
Mm.
airflow can be maintained appropriately, and that will pose a less requirement for the cooling. So
Correct.
I think that is the main reason why they are having a warehouse kind of infrastructure. But in Mumbai and whatever they may be having planned, because they have started with Mumbai, and because again we cannot have this much of a space within Mumbai where we are having
Correct.
acres of
Correct.
land, so
Mm.
that's why they may have planned it as a multi-story building. I have met one of the person from Yota as well, but he was from
Uh,
the sales side. So I asked the same question to him that why why this difference is there, but because he was from the sales side, he was not able to answer it.
correct. And
Right?
it's a huge principle difference in the thought process
Obviously,
that.
yes, yes, yes.
And then if it is kind of
Even in
located
terms
in.
of disaster. Say
Mm,
if
mm,
disaster happens, then
mm.
also if you are going with a multi-story infrastructure, then the losses you will be incurring will be heavy as
Humongous,
compared to
correct.
if you are going with this
Warehouse kind
kind
of a
of
setup.
warehouse kind of infrastructure.
Mm. That is true.
I'll
That
still
is
try
true.
to find out that what exactly is the case.
Correct. And
Okay.
see, those are business people. They must have thought about it, but
Yeah, yeah,
it
obviously they
looks
are
like
the
a very principle shift in thought process, and
yes,
that
yes,
might that needs a clear-cut understanding and handling in a way.
engineering. Yeah,
Hmm.
Okay.
And even the
So
heating, if you have it located in a crowded area, then heating requirement even bubbles up further. If you
bubbles
have
up,
it in a
yeah. If you are having in an
remote area,
isolated area, yeah,
hmm, and correct cooling
they may
requirements,
have it.
as in natural cooling related stuff also can be organized. If you see the other data center pictures which you showed, there
Yes,
were
yes,
ponds and lakes and
yes,
trees
yes, yes.
around.
That can be
But
planned, but here
here
even
nothing
that
can be
option
done.
will not be
Hmm.
there. Yes, yes.
So handling
So
that
still,
heating
I'll
and
try
cooling
if I can
requirement.
connect
Hmm. Right.
to someone from the technical side and can have the answer for this, how they have managed it.
It was just out of curiosity, nothing
Yeah,
beyond
yeah,
that.
no, no. Definitely. Means at least how they have planned, we should know that what measures they have taken.
Hmm.
Yeah.
And another surprising part was the data center inside sea. Now, if you have something inside sea, how that can be maintained?
Yeah. No,
That
no,
was
that
it.
is somewhat
Hmm.
practical. Microsoft used to have it, and recently they have closed, I think, two to four data centers that they were having within the sea. Maybe because of the operational cost or so. Because definitely cooling is one factor that you are getting within the sea, that okay, somehow the cooling requirements will not be that huge within the sea. But
Correct.
apparently, rest of the operational things, maintaining the staff, or whether it is going it in an automated way or what. So I think because of that, they have dropped the idea and closed the data centers.
Okay, because see, human intervention is required, plus you need to
Obviously, means not
kind of
consistent, but at least a bit
mm,
of intervention will be required.
right. So getting inside data center and coming out of data center, which is located in sea, that's practically pretty difficult, right?
Yes, yes. Oh,
Not really
definitely,
sure.
they might have some tunnel or such kind of thing where they might be entering.
True.
Yeah,
But that looks pretty difficult to imagine
interesting.
that way. Mm,
Yes, yes. So data centers, usually we can have a comparison between traditional and cloud data center, because if you recall, then we have talked about that initially there were traditional data centers, but nowadays the shift is totally towards the cloud data center, right? So this is just a comparison in terms of servers, where in traditional they can be co-located servers within the data center, and here in cloud it is integrated and fault tolerant, in the sense that we are using the virtualization, and because of the virtualization and appropriate replication, we can assure the fault tolerance over here. Resources in traditional data centers were partitioned. Here it is unified, in the sense that a pool is there, and within that pool, we are creating the virtual resources, and those virtual resources are being handed over to the customer. As far as management was considered in terms of the traditional data center, it was separated and mostly manual, but with cloud data center, it is centralized with full automation, because we have already have seen that the software layer is appropriately maintaining the whole thing. Scheduling, we have to plan ahead whenever it comes to traditional data center. Over provisioning may be there in terms of traditional data center, because virtualization was not the concept that is being utilized, and that's why, because physical resources are to be extended, ultimately there can be a case where the service provider may end up in over provisioning of the resources, right? Renting per physical machines, I already told you that virtualization was not there, and that's why remote access used to be given per physical machines, right? Services, some designated servers can be used to be utilizing some kind of services, say it be what web servers or so. And here in terms of cloud computing, we will be having the services running across various virtual machines. In the same way, you can go with the location, scalability, repairing and upgrades, and cost. So that's quite obvious because here the location will be on premises, physical proximity to the organization. If we are comparing it with the on premises, while in case of cloud data center, it is virtually scalability in traditional data center. Again, scalability will be somewhat restricted, but here in cloud, there is a concept of cloud bursting as well. And through cloud bursting, these cloud service providers can expand their capacity beyond their actual capacity by getting services from some another provider. So that is an extreme case. Still, a lot of work is going on into it, but again, it will be possible. Repairing and upgrades, obviously, because this is somewhat physical in nature, that is being given. While in case of cloud, we are having the concept of virtualization, and ultimately we are delivering, getting the machines through the pool only. So that's why we can say that, okay, it is centralized, full control and automation. Cost, it all depends that in traditional data center, the cost was somewhat high because ultimately the data center at the other side is acquiring resources physically, and there is no option of virtualization, so that in case if your resources are not being utilized, at least some another resource will be some another provider or the some another consumer may be utilizing the resources. So that's why somewhat high. While in case of cloud data centers, because it enables extra resources with additional payments, you can have a lower cost as compared to the traditional data center. Okay, so we'll have a quick 3 minutes break, then we'll resume with the data center architecture. Okay, resuming the session. Um, there is some construction work going on, so I just would like to check if you are hearing clear voice or not. Just let me know, otherwise I'll try to change a bit. Anyone? Okay,
Very
I
clear, sir.
think, okay. So Teams noise cancellation is working, I think. Yeah.
Yes.
So, so this already we have gone through that what are the main components of a data center. There is a bit of addition to it. So just for your knowledge, you can see that there is a power distribution unit which will be there, and this will be responsible for distributing power at every place within the data center. So definitely capacity will be there in kilowatt or so, and apparently this power distribution unit will be responsible for distributing the power at different places. Not only this, these power distribution units will be working in sync with your backups, power backups, say it be the UPS systems, right? So not only UPS systems, but also with the generators, because ultimately the whole concept is of power distribution. So within power distribution, UPS and generators need also to be taken care. Say it be if when main supply is not there. So apparently we can work through it and have a uninterrupted power supply. Okay. So if you see, then we are having UPS systems over here, and generator may also be there. So these are the pump rooms where we will be needing to pump the cooling solution, right? And these are the generators, right? So all these three units needs to be worked in sync. So the generators, the UPS, and the power distribution unit. So all these works in sync, because if you go through logic, ultimately some kind of switch will also be required. Why? Because whenever the main power supply is down, so at that time you should be clear about that, okay, the generator should be put on, and when the generator, when the main supply is available, at that time the genset supply should be cut. Okay, and then apparently you should be able to get the uninterrupted power supply. So this is somewhat very much required, and this switch should happen without any kind of interruption, right? Because these are the computing devices, and these computing devices are ultimately working through some sinusoidal waves, right? So in initial days, if any one of you have ever encountered, so what was happening is, even when people are using inverters, right? So even after using the inverters, what they were facing is that apparently as soon as there is a switch in power, so what was happening? There is a restart, system restart was there, right? So system was restarting as soon as the power goes. Definitely the supply is there, but because the inverter that usually came earlier, so they were not utilizing the sine wave. Ultimately, these square waves were there, and because of that, apparently, whenever power supply is cut, there is a sharp shift, and because of that the system gets restarted. So what used to be done during that time is ultimately UPS is to be there, and supposedly inverter is there, right? So as soon as the power cuts, the supply shifts to inverter, but apparently the system is being connected through UPS, right? So UPS used to take care about the sinusoidal wave and the continuous power supply, and because of that, uh, the system was not restarting if we are having this particular configuration, right? But nowadays, when we are having sine wave inverters, so that way it doesn't pose any problem nowadays, and we can omit the use of UPS in between, at least at the home, because the inverters are usually utilizing the sine wave. But this is not true in terms of generators, because ultimately generators doesn't supply consistent energy. So for IT equipments, at least we should be having the concept of inverter, this UPS, right? So we will see in future that how exactly this is being carried out in terms of UPS and other systems, right? So PDU, then UPS, and this is the generators that we have seen. For air handling and cooling units, just like heat rejection unit, then pump rooms are used so that whatever be the coolant, so many times the cooling is being done by coolant, and this coolant is responsible, this coolant is being flown throughout the surfaces through the pipes, and because of that the overall cooling is being carried out. So that should be pumped somehow, and uh, through that ultimately the cooling is being carried out, right? Apparently we will be needing the heat rejection devices, then this air handling units, what someone from you have already talked about, Yuvraj has was saying that somehow we will be needing the airflow in a proper way. So complete units are being there corresponding to this computer handling units and so. Okay. So this is one case. Just let me know whenever there is some noise. So I'll try to shift my position. So, right. So this is the case, and apparently, apart from this, you can see that switch gears are there. Okay. Can anybody tell me that why these switch gears will be required? Yes, anyone?
Is it to switch between the various sources, as in if we use diesel in order to generate the electricity, or inverters or main supply?
Yeah, correct.
Uh,
So Yuvraj is correct because ultimately switching will be required whenever the source is being changed. So if it is being changed from generator to say it be UPS, or say it be generator to sorry, the main power supply to generator. So apparently switching, automatic switching will be required, because we cannot assume that a person will be sitting over some location, and then based on the electricity supply he will be making a decision that okay, the switch is to be made. It should be automatic in nature, and that's why we will be needing the switches. These kind of primary switch gears, electrical switch gears will be required, so that automatically switch will happen as soon as power supply is resumed. Automatically the generator supply should be put off, because we cannot provide both the supply in parallel, because if you think it from the electrical perspective, we understand that the current will increase even when the voltage remains same, but when the supply is from both of the sources, then the current will increase, right? So that is the main logic. Definitely for generators, we will be needing the fuel, oil, storage tanks and all. Then co-location computer cabinets, that's quite obvious, and co-location suites will be there for having the consistent supply and having the racks placed. So these are usually called as pods. We will see what exactly these pods are all about. So you can see this we have already
Sir,
seen. These we
s-
called as
sir,
servers. Yes,
question on
Yuvraj.
earlier slide.
Yeah,
Question
yeah.
on earlier slide. Can you talk about hit rejection devices and how they're used?
So in earlier days, these heat rejection devices were used. Say it be again, we need to take the benefit of physics into it. So usually the terminology that they call it as aisle, right? So
ISL.
yeah. So mm, what will be the case? Just like I have shown you one rack. So if that rack is placed like this, that front side is over here, back, which is blowing out the air, is over here, right?
Mm-hmm.
So I have placed the racks like this. Okay.
Mm-hmm.
So again, in both of the cases, things are common that this is here, this is the front, and here, this is the front, right?
Mm-hmm.
So again, in both of the cases, the heat is being blown out in this area. And
Okay. Mm-hmm.
supposedly, if I am isolating this space in terms of some kind of infrastructure, that the air over here is not mixing with the air inside. And now from here, I'm using some what I can say the fan or some kind of blower that is blowing out the heat from this particular area, right? So
Mm-hmm.
these kind of devices are usually called as heat rejection devices, right? So
Okay.
coolers, chillers, or ultimately they
Oh,
use it with this particular principle, which is known as we usually call it as hot aisle, right? So
mhm.
these kind of
Conceptually,
devices,
can we
yeah,
compare this to exhaust fan which we have in kitchens typically, just to blow out the hot air?
yeah, chimney exhaust fans, you can see like this.
Mhm. Okay. Even if you consider the bigger warehouses, even today, they have a fan kind of a arrangement on their roof.
Yes, yes,
Uh,
chimney, and all these arrangements are usually there.
okay. So all of those are heat rejection. I was curious about that rejection word, how they reject the heat. So they kind of take out the hot air from that particular passage and blow it away so that cooling
Yeah,
can be
that way
maintained in a
they
way.
are rejecting the heat from the premises. So that is the main idea,
Okay, thanks.
right? So you can just see that coolers, air cooled chillers. So that is the advanced part, but this we can mix it with the basic aisle, that is hot aisle that we can mix, and we can reject the heat by this blowers.
Yep, agreed.
Okay. Yeah, yeah. So in traditional data center, we are having clusters just like I told you. And these are the racks placed. The racks are being connected through this cables, and ultimately this may be your network switches placed over here. Servers we already have discussed. So this is 19-inch rack cabinet. This is just a picture. So those who have missed the video or haven't gone through the video, you can see that this is one rack, right? So this way servers are being there corresponding to each rack. At the top, you may be having some power arrangement so that all of these powers can be maintained corresponding to all the servers. These power cabling are coming and traveling throughout the infrastructure through these particular cables or this area. So this is one combination that they usually carry. And there can be some another combination as well where they usually lay down the cables down the line. So that is again one combination. It all just somewhat analogous to the electricity cables. Usually that happens within the what we can say townships. So in general, earlier it was over and above the surface, and nowadays they have started deploying it underground so that it should not be visible and somewhat clean arrangement can be seen. So both of the arrangements are possible as far as the data centers are being considered. So either the networking cables, because two types of cables will be prominent. One is the networking, and other one will be the power cables. So that way, these cables are laid down through this particular area. Right. This we have already seen what are the various types of rooms and all. Major contribution for the cost, we already have seen that space is one, then power is another, where we will be needing the power for running of the servers, storage devices, and networking devices. And apparently, the heat that is being generated out of these devices, we will be needing cooling. And that's why this cooling is again one major factor for the power consumption, right? And because of this, capacity planning will be needed whenever we are dealing with the data centers. Then, based on the area, based on the server locations or data center location, we should be, or the data center provider should be doing the capacity planning in terms of the current need as well as terms of future need, as what exactly may be the future expansions that may be going on or future requirements. So some percentage can be thought of that, okay, in future or in upcoming 5 years or so, overall the systems will be requiring this much of upgradations. So all these capacity planning needs to be done from the data center provider. So just have a look at the various things they need to think of. So it can be building a brand new data center, purchasing or selecting co-locating or co-location space, right? So these two options are there. So building a brand new data center or purchasing or selecting a co-location space, just like the example of Yota I have given to you. So they are providing this co-location space as well. And many of the service providers nowadays have started delivering such kind of co-location services. So you might have heard about the co-location workspace, right? So co-working space, you might have heard about. So same is the case with the data center or the server infrastructure is being considered, because apparently what you need is security, what you need is internet, then power, uninterrupted power supply will be required, then cooling will be required. Not only this, security in terms of physical uh, and security in terms of the concept that okay, firewalls and all these devices will be required, right? Supposedly you are not you are sure about the hardware that okay, this hardware will be procured and this hardware will suffice for upcoming 5 to 6 years. Okay, so if this is the case, then And if you are not able to, or if you are not willing to get into the hassle of maintaining all these things, just like security, internet, power, cooling, firewalls, and all. So in that case, you can opt for the co-location space, right? And service providers like Yota and many other are nowadays have started these kind of services where you can do the procurement, but for all these services like security, internet, power supply, and all, they will be providing you, and the revenue model for them will be the rent that they will be charging the rent corresponding to the devices that you are having. So this is yet another concept growing in terms of the field of data center. Capacity planning may be required for expanding the existing data center capacity or consolidating the existing data center, right? Moving or migrating current business applications into the cloud. Again, that may be one case. And business continuity facility, say it be you have done the analytics that okay, this much of resources will need to be procured further so that we can meet up the requirements of the consumer. And maybe capacity planning will be required for the data center relocation. Say it be Microsoft has closed the data center within the sea. So ultimately, whoever be the consumers, those who are using the data center, they need to be shifted to some another place. So that relocation, if that is to be done, then in that case, again, you need to do the capacity planning. In case you have not got the concept, you can go to the verbal meaning of capacity planning, which means that whenever you are planning any data center, whenever you are planning the expansion of the data center, whenever you are planning the shift of a data center, apparently you need to appropriately do the capacity planning of the infrastructure, not only in terms of IT, but if you have done it for IT, then correspondingly, what are the other inferences that you have to do in terms of power, in terms of backups, in terms of cooling and all. So all this planning needs to be done whenever any of these activity need to be performed. Okay. And apparently, this was the major case. And apart from this, you need to think about the performance in terms of service level agreement, whether it is in line with the service level agreement or not. And uh, the overall maximum capacity that you should go with, right? So these are the steps usually to be followed whenever capacity planning is to be done. So first we'll measure that how good the data center performance is, whether that needs any kind of change, shift or so. So if yes is the case, then here you need that capacity planning to be done. And then whatever be the changes that are being suggested, those changes can be done, and apparently the data center can be upgraded, right? There is very common term when it comes to data center, that is scale up or scale out, right? So scale up, many of you might be knowing this, that okay, so whatever be the powerful CPUs or more cores, more memory can be drawn, right? So that is known as scaling up. So this analogy, if I would like to give, so it'd be if you are shifting from a i5 system to i7 system. So this is your scale up. Okay, because here you need to change all the things. Say it be even if you are keeping your server rack same, or say it be server cabinet same, then also you need to change the processor, you need to change the motherboard, you need to change the RAM in case if the RAM is of a different category, right? So that's why it is called as scale up, or usually it is called as vertical scaling. Just remember these terminologies very frequently used in terms of cloud and hardware, right? Scale out, adding more low cost commodity servers. Say it be i5 was there, let it be. So maybe the case that I was having 10 cores or so. Again, I'll add up one more i5 server to it, and again means if somehow by virtualization or so, if I can pool the capacity and I can utilize the combined uh, power of these two i5 systems. So maybe the thing that I would be able to reach to this kind of performance. So this is known as scale out. And uh, in terms of scaling, it is called as horizontal scaling, right? Power usage effectiveness, I told you that it is a measure of performance, or it can be used as a measure of effectiveness in terms where whatever be the power you are utilizing, say it be if you are utilizing 100 unit. So out of this 100 unit, how much unit are being consumed for the IT equipments or IT systems? I hope you got an idea and you may be able to derive the formula as well, right? So ultimately it's a ratio. So power usage effectiveness, if I'm saying that it is a ratio, then it will give, suppose whatever be the total power that is being utilized. So if I'm dividing it with the power utilized by computing equipment, right? So if 100 units are being drawn, and if 80 units are being utilized by IT, the rest of the 20 are being utilized in, say it be, what we can say, cooling. What else? Yes, anyone, if you can think of, apart from cooling, what, wherever, where the other requirements will be there. Nothing technical into this, just the common knowledge, whether, uh, yes, anyone?
We had various electrical systems which will need to be maintained. So they too will require electricity, power consumption.
Correct. What else? Say it be lights, fans, etc., or whatever be the rooms that are being maintained apparently. What else?
बिना बनाए रह नहीं पाएंगे ऐसा मुलायम रसीला और दानेदार सूजी का हलवा आज हम बना
Sorry for this. Please be careful with your mic. Apart from this, this is somewhat very technical. Just like UPS. What happens is UPS batteries needs to be charged in case they are being utilized in case of any kind of powered shut, right? So that's why ultimately UPS batteries will be charged, and that power requirement will again come within this category as well, right? So this way we will be having cooling, lights, fans, and apparently UPS batteries and any kind of losses that are happening. So all these will be contributing under this category. Okay, and because the devices, whichever be the devices that are being there, these power devices, they usually comes with a f- power factor. If you have ever seen, right? So they come with a concept of power factor. We will see further. So all those losses will come under this category, right? So apparently we can say that it is uh, 800 divided by 80. So it is apparently 5 divided by 4, right? So it will be 1.25, right? So the POE ratio in this case will be coming to 1.25. And by having this idea that, okay, what exactly is the PUE ratio, we can check the efficiency with which the data center is being operating. Okay, so 1.25, I can see that, okay, um, 100 is the consumption, and out of that, 80 is what is being utilized to the IT equipment, and rest 20 units is being utilized for the non-IT things. Okay, so
Sir, sir, I
yes,
see
Yuvraj.
the problem with formula is should it be total power should be in denominator and power utilized should be in numerator? Let's say out of 100, we are consuming 80 for useful purpose, right? So it's 80% consumption. It
Yes,
cannot be. So this is
it's all the
1.25, right?
outlook that you would like to have.
Mhm. Okay, out of 100, we are consuming 80 for useful purpose. So 80 should be in
Yeah.
numerator and 100 should be in denominator. That's what I think.
Okay, that is again correct. What you are thinking of, and I think it may be the easiest way, but I don't know why they are doing it this way. But the industry is measuring the power usage effectiveness in this way only. That if you
Okay.
see the further slides, so this is the case. You just have a look. So 1989 to 2005, they call it as Generation 1, and the POE usually goes over and above 2. That IT equipment, if we are consuming 100, then overall power consumption is going to be 200 unit. Right, then generation 2 came 2007 or so, the power usage effectiveness. What you are saying is very much correct and logical, because if I see that, okay, if it is zero point 0.8, then easily I can measure that, okay, zero point 0.8 is being utilized, or 80%, if I say, then 80% is being utilized over here in the main IT equipments. But somehow the industry is following this practice. You can see generation 3 to 1.2 to 1.5, 1.2, and now they have started reaching, because with the software defined data centers and all, now they are able to achieve 1.07 to 1.19. Obviously, it cannot be made one, right? Because
Mm,
apparently you will be needing some additional power things, just like lighting, electricity, and cooling will always be there. So definitely we cannot achieve as one, but I think now considerable achievement has already been done, where we are able to achieve up to 1.07, 1.19. So it's a matter of outlook only. What I feel is
okay.
that
Hmm.
with what outlook you are looking into it, you are looking at it from the percentage perspective, right?
Hmm.
And they are looking at it from the perspective that, okay, if something is total, and among that total, what exactly is being utilized. So that 1, 2, 3, apparently 1.5 is giving them an idea that, okay, what exactly is the case. If it is 1.5, then so you can have a simple mathematics within your mind that, okay,
Hmm.
150 units total and 100 units are being utilized within the IT, right? So
Hmm.
I think it's a matter of outlook only. Still,
Okay.
that is a good question. I'll think I'll go through it whether there is a specific reason for having this kind of strategy rather than going in a percentage way, which is somewhat more easy. Even I find it
Right.
somewhat
Mhm.
easy that okay,
Correlate
80%,
also.
yeah, so we can correlate it as well, and we have to put less effort for calculating even that what exactly is the case.
Hmm.
So we'll see.
Okay. Sure.
Yeah. Challenges are huge. Cooling, we already have seen that cooling is one of the biggest challenge. Just assume that when it is a summer season and you're having your laptop on your lap, the heat that is being generated by a laptop only, which is having a single processor, is considerable. So just assume that when n number of servers are being running. So right now, the cluster that I'm telling you, so the cluster is having H100 NVL GPUs, and four such GPUs are there, and each GPU is having 92 GB capacity. Apart from that, the GPU node is having 2 TB of RAM and two Xeon processors. The compute node is having four Xeon processors and having 256 GB of RAM. And same way, controller is having 128 GB of RAM with I think yeah, a Xeon processor. Storage is also there. So for this configuration, where we are having a room of 100 square feet, uh, in this summer season, we are having 2 ton AC. Uh, that's to industrial grade AC we require, and two such ACs are required, and still the temperature is around 20 degrees centigrade. Uh, so even we are thinking about it as how this cooling can be maintained. So cooling is a major issue that you can assume that 2 ton AC with industry grade, and even when two such ACs are being placed within an area of 100 square feet, and with this minimal configuration that we are having, still we need to put a check on this, right? And as a layman arrangement, what we have done over here is we have uh, applied a circuit to the room where we are having a temperature sensor, and that temperature sensor is giving a reading to RPI, and RPI is apparently broadcasting it through that communication channel. And in our app, there is one app known as something Blink IoT, and through that we are getting the readings, continuous reading. So right now we are monitoring it as to what extent it is going. Right, but cooling is again what why I told all you all this is means it's a huge problem, and you can see by the pipes that are being laid down within the data center. So apparently, it's a major issue, and industry try to cater with it in different ways. Say it be the hot aisle that I already told you. There is a concept of cold aisle as well. So cold aisle in the sense that the face will be there within this particular area. This area will be cooler comparatively, and the hot air will be outside and will be catered by the cooling devices. Right, so you can just have a look. First one is the conventional cooling, second one is the cold aisle arrangement, and the third one is the hot aisle arrangement, and fourth one is the thermal modeling. We will see further what exactly we mean by all this. Energy proportional computing, this is yet another challenge, maintaining the PoE of corresponding to the data centers, right? So whatever be the load, correspondingly, if my energy is proportional, so you can see that based on the utilization, the variation in the load is heavy. Say it be the CPU, what CPU is carrying, DRAM is carrying, HDD, and other. So it's not in proportion as compared to what exactly is being drawn by the IT devices. So that is varying. So again, that is one of the challenge. Servers are ideal most of the time. If servers are ideal, then apparently how the cost needs to be handled. Just like the AWS Spot instances, if you have ever heard about. So AWS throws its instances known as Spot instances. So whenever they are having some free capacity, so they release the resources, the EC2 instances as a Spot instances, and the pricing of these instances is somewhat uh, only 10% of the overall pricing, right? So in case you are having something that you can run for say it be an hour or so and get the result. So rather than on demand instances, you can go for on spot this spot instances. So that way the pricing that you will be paying is merely 10% of the total that you would have paid with reference to on demand instances. This is just to cater with this, that if the servers are going ideal, so at least if you can get some load to the service, efficient monitoring, obviously just to maintain the service level agreement, whether the objectives and service level indicators are being met or not. So maintaining that is again a challenge. Okay. Uh, so for efficient monitoring, ultimately different architectures are being utilized. Say it be this is a common architecture where you are having all things on a single server. Uh, so this can be a GPU server, this can be general server. This is yet another server having some another local storage, right? Uh, just have a look. This is disaggregated rack architecture, and can we achieve this on a virtual node? Right? So can we virtually have a system where we will be combining the CPU, memory, and GPU uh, as a single system? But again, for this, we will be needing the virtualization. And all these services should be software defined services. Then only we will be able to get this connected. Ultimately, we will be needing a pool for this, and out of this pool we will be deriving the resources, and apparently we can monitor it, right? Managing scale and growth, obviously that is one of the challenge. Networking at scale, handling these much of wirings will be a huge thing, and that's why if you see the images within the data centers, so either they are running at the top or running at the bottom, but still, if you are having servers, then within the servers itself, you have to maintain a lot of wires, right? So power, next topic is power. We will go through this power tomorrow. So the session I missed on 28th because 28th there was one event at my parent organization. So that's no, not 28th, 21st. So I'll be compensating it tomorrow. So if we see the calendar, I've asked it to. So you are having something in the morning or what?
We have 4 sessions tomorrow, sir, unfortunately. Today we had 2 sessions, but
Okay, okay.
one of our subsequent session is also pushed tomorrow.
Yeah, that's why I asked them that morning, if it is possible, then it will be good for both of us, means for you people and for me as well. But they have given me the time slot from 1:30. Okay.
Yeah, all
So
of them are
tomorrow,
kind of like entire day is packed tomorrow, if you see it
got
that way.
it, got it. Okay. So we'll start at 1:30 as per the schedule, and it would be somewhat interesting because tomorrow we'll be finishing up the data center and we'll be starting the concept of virtualization and containerization. So some practical aspect of containers, creating the containers will also be there, right?
Yeah.
So going forward,
Good.
we'll be also having some practical on spinning up and the infra, right? Configuration, automatic spinning up.
Yes, so the first assignment I am planning because it is already being delayed. So first assignment itself will be having practicals related to creation of virtual machines, creation of containers, and not only this, I have created a class on AWS Academy. So that is related to cloud foundational course. So that is having sessions related to virtual machines, session related to auto scaling, and apparently networking. Uh, right. So that way we will be utilizing that AWS Academy class so that you can do practicals, hands-on practical to the AWS network, right? I hope in any earlier semester you haven't gone through this AWS Academy course. Have you gone through it?
No, I don't think either of us has went through that.
Okay. So the best part is BITS is having subscription of AWS Academy, and through this you can go through various kind of certification courses. Right. So one of the foundational course is AWS Cloud Foundation, and I have created one class for this. I'll enroll all of you into it. Today, by today evening, you will be getting a mail from AWS Academy. You just have to create your account. It's a separate account apart from the bits, means it will not be a single sign-on. You have to remember the password separately for this particular Academy account. Okay, and
So that is a
that
free
way,
account or we it's a paid
yeah,
for
that
us?
is a free account and nothing
Okay.
to be paid. I never believe in spending money from my students, right? So it's a free account, and best
Uh,
part is if you go through the complete modules, you will be ready for a Cloud Foundational certificate. So if
okay.
you would like to go through the certification, then also I'll be helping you out into it. But my main focus is so that you can go through the practicals of virtual machine, auto scaling, and apart from that, the networking and storage part, so that you can have a realization as how exactly things are being carried out in cloud, right?
Okay.
Yeah. So
Yeah,
today you'll
that's
be
very
getting
good.
the mail corresponding to that, and tomorrow I'll just brief you as how exactly to utilize the whole course for maximum benefit. Okay.
Sure, sir.
Yeah.
Sure, sure.
Sir,
Yeah.
you will be
That's all
messaging in
from
the Teams, right? The quiz one once you open
quiz.
it.
Yeah, I'll go through the setting that whether you are having access to the questions or not, those who have already appeared. If so, if not, then I'll open it. If they have access, then in that case, I'll upload 20 other questions. Okay.
Okay, sir. Yeah.
Yeah.
Thank
Okay.
you.
Yeah.
Thank you.
Sir, primary challenge as far as your the course which you talked about, AWS course is concerned, is the time management. As in, it's becoming like it's fairly difficult for us to spare extra time beyond what we are doing right now. So
It's
from
not that tough. Let me tell
okay,
you, my niece is in third year,
okay,
and I just told her that okay, this is the course, and she is an average, above average student, and she was able to do it within 5 to 6 days.
okay.
Yeah, so you can think about it means
Hmm.
if you think that okay, you will be doing it, definitely you can achieve it. In all other way, at least you can get the academy certificate. Once you go through all the modules and all the labs,
Hmm.
right? So after that, you will be getting an academy certificate that okay, you have gone through this academy course. So ultimately, you should have the knowledge. Certificate is merely a piece of paper, and if you can confidently claim that okay, you have gone through the course and you know the basics, so even that academy certificate will do. You don't have to appear for any kind of examination,
Okay.
right? So I'll tell
Uh,
you tomorrow
mm,
about all these things. Yeah.
okay.
Anything
Thank you,
else?
sir.
Yeah.
That's fine. Thank you. You're good.
Okay.
Thank you.
Thank you. I'm ending up the session. Thank you.
Thank you. Thank you, sir.